Alright, here's a little note on how to get your homework number 5, or at least the Jupyter part of it. Alright, so log into Shannon under your username. This is my student sort of account. Get like this, go to a terminal. This will be the best way to fetch your assignment and how we'll do it in the future too. It's nbgrader. Use the tab key to do that, nbgrader, and you can just hit enter and see what you can do. Up key, and then list, nbgrader list. That tells what we have. I see 490 info, homework 5, hw05. So 490 info is the course name, hw05 is the assignment. If you want to get this, get your own very personal copy of this, you say nbgrader fetch homework 5. It says no course ID specified, run with course flag. That looks like this. 490 info. Okay, it fetches it. Source, destination. Alright, this is all nice. If you look up here, this will refresh in a second. You can also refresh the file list with this button. Homework 5, you get a new folder here. If you type L in the terminal, you can see that listed as well. Let's go into this folder. I'm going to close my Control D, finish my terminal session. There's 2 items in here that are important to you. Text entropy. This is just to read. Okay, you can ignore the first 2 items. They're just added automatically. And then Shift Enter to go ahead and execute these as you go. Scroll down. This is familiar from last time. Documentation for how collections work. It's a bunch of nice things. Requests is the package that does the downloading. If you want the documentation, it's there. Please read this. Go through. There's a difference between bytes, which are 8-bit entities, like we might call them uint8s in C, and strings, especially in Python, but basically everywhere else in the modern world. And I hope we're doing modern stuff. Difference between strings and bytes. Please read this. If you come from the world of C, which you all do, this is just, it may be a new thing. So please read the text, scroll down as you're going through here, execute these and see what happens, and read the code and see the examples. So you go all the way down, do that, do that, do that, and a little bit of extra things. Remember, we use this for making our pairs of histogram. Alright, that's that file. I don't need to save that right now. Your problems are in a notebook called Problems. Alright, now you can add your name here if you wish. Names of people that you collaborated with is good. If you work with others, that's perfect. Please ask questions in Slack channel. And we go down here. This is our same imports, and this is a different function, get URL bytes. You know about this by now because you read text entropy. Alright, now we have a couple books, just a couple books I chose off of Project Gutenberg, and here's where your assignment starts. I would like you to create a function to compute the probabilities of certain text. So there's a couple example texts up here. One is called Electrons Book. It's like a day in the life of electron or something like that. King James Bible, the whole thing, 4 megabytes worth of text. So create a function. It's called probabilities. It takes B, which B is this bag of bytes up here. Right now it raises a not implemented error, but what you do is you replace that with your code, whatever you decide to do, and then you return your counts, or whatever this is. So you really started this last time, but this time it's for real. What happens is your task is to make the code that's in this box, make that function that works. By the way, you can add other functions. Where's it at here? File, you can add a cell. Where's it at? Add a cell. Well, if you type B, you make a new cell below. DD deletes that cell. There's some other keyboard shortcuts. All right. What happens is these cells down here, they're not, you can change them now, but what they are is they're saved in my database later. See how I can't edit these? I can highlight the stuff. But these are tests. So if you type probabilities of AAA, just 3 A's in a row is my string, I should return a dictionary type. So that's your hint, and it says up here, return a dictionary. Also, all of your keys should be integers in range 0 to 255, because these are bytes viewed as unsigned integers. Compute them right here, and then this is a little bit of code that does that check. Another check, these are probabilities. All of my probabilities need to sum to 1, and if they don't, then it's going to raise an error, and you don't get the point for doing this. You can execute this code. See, right now it says it doesn't work because probabilities is not defined. Oh, let's define it. Okay, and let's run it. Oh, it doesn't work. So when these tests pass, your function is doing okay. That's how you can know. Another one, let's see, I talked about that. Problem number 2, compute the information in a set of byte values found in the file. We have the probabilities. I want you to convert the probabilities to bits of information. This is called Shannon information. The McKay book talks about that. I wrote it on the board last class time. Put your code here, compute entropies, and this is another dictionary, but the values in this dictionary are units of bits instead of probabilities less than 1. If the probability of a heads is 50% and a tail is 50%, each one of these is 1 bit of information. That's what your function called information should return. And then this one, I'm just checking that all your probabilities, or all of your information. Oh, this is a bad check. It'll still pass. All right. This will be all less than 1 anyway. All right, so that's a bad check. So we have number of bits, information bits. Total number of information bits has to be less than or equal to the total number of bits in your file itself. We'll talk about that. That's a bound or pigeonhole principle as we get more into this information theory stuff. So create a function called information. Talking a little long, so number 3 is compute the average entropy of a file. This is entropy. This is the summation. It's right in the McKay book, right after defining Shannon information. So look it up. Write a little function. I got you a little bit started, gave you a couple lines, and then you're going to return your answer. It's going to return a average entropy of the file in bits. It's going to return a single floating point number. This file right here is one of my checks, is half ones and half zeros. Its average entropy is 1 bit because there's only 2 choices. The average entropy of a file filled full of zeros is 0 because that tells me absolutely nothing. And really interesting, these are the answers that you should get for those very long books. 4.5, 4.6 bits of information per byte. After you get all of these tests to pass, go ahead and go down here, and you can you edit these? I don't think you can edit these, but you can extract some more. There's a little bit of discussion that I've put together about file compression and information bits and such. I hope by the time you get down to that, you say wowza also. That's all I have to say. If you have questions, you know how to find me in the Slack channel for this class.